Hello everyone, welcome to the first tutorial of the course Cartographic Visualization in GIS. Last year we used to keep these sessions in the GIS lab, and it was just too much meeting for us and for the students, and most students were anyway following the tutorials online, so we decided to go the online way this year. And of course, we have the help sessions every Wednesday. So if you have questions, if any part of the exercise or the tutorials are not clear for you, you can of course ask questions from us on Discord or go to the GIS help sessions and get help from the course's assistant. Yeah, so I already explained in during the lecture, but the idea of tutorials is that it's not exactly the same as the exercises, but it provides you with some new skills every week that would help you make better maps in that exercise that is given to you for the week. So that's the general idea of the tutorials. So you don't be surprised if it's not exactly the same as the exercise. That's the idea. So as we already explained, the exercises, the tutorials are divided into two parts. So we have two separate videos. This is the Python version that I will go through with you. And there will be another QGIS tutorial. So we make almost same map. Again, the maps will not be exactly the same because we are a bit limited by the tools that are available to us, but the maps are generally the same. One is made using QGIS and the other one is made using Python coding using open libraries. So that's the idea of the tutorials. And now we are going to start tutorial one, working with Python to create a simple thematic map. So I will go, most of you have probably taken other courses where you need programming for doing GIS, especially AutoGIS or GeoPython, so you should be familiar with this, but as a quick reminder for some of you who might be from other programs or may not have taken those courses. So on the courses web page, under general information, you can find a link to CSC Noppe. CSC is this cloud computing environment that is provided to us in Finland for those of us who are working in universities, educational organizations. So we are going to use Noppe from CSC. What you need to do is to log in. And of course, there are different ways how you can log in. I'm just going to go log in using my username and password. Once you log in, you'd see a number of environments that are by default there, or some that you might have joined before. You will not see the same list. I have stuff from other courses. But for the first time, you have to join the workspace, and there's a button up here. If you click Join Workspace, it will ask you to enter a join code, which you can find from the courses page, same place. Under General Information, there is this core code that you can just copy and paste and join the workspace. And then you should be able to see this Cartogis 2025 on your screen. I'm not going to do that because I already have it listed here. So I'm just going to launch an instance and start working with Python. Depending on available resources, this might take just a couple of seconds or even up to a minute or two. Uh, now it wasn't too slow, so hopefully it works fast for you as well. Okay, so as a quick reminder, for those of you who have taken this course, taken similar courses before, or this might be new for you if you're using Jupyter Lab for the first time on CSC environment, you have two folders here. One is shared, one is my work, and of course this is the root. So we don't use shared much unless we, as the course instructors, want to share something with you, but let's not go there now. If you save anything here in the root folder, next time you open an instance, it will be gone. So do not save anything here if it is important to you. Instead, whatever you're doing, if you're doing your exercise, if you're doing the tutorial, just use the My Work folder. Here I have another folder that you probably don't. and these are my old files. So, but for you, it should be empty. So whatever you do here, it will be preserved. Next time you open an instance, your files will be there if you have saved them there. So this is an important thing. Remember to do everything you do in the my work folder. So the next thing we have to do is to get the materials for the week's exercise and tutorial from the course's website. If you go to course environment, there is a link to a GitHub repository, tutorial repository. It's an open repository, so you do not even need to have a GitHub account to access the course's materials. So let's just copy that link, and then from here we can access the GitHub plugin. I'm going to choose clone a repository, and we are going to clone a repository. I will just paste the link I copied from the course's website and and start the cloning. Okay, so now you see that there's a new folder created for you called tutorials. Now there is only one subfolder inside this folder, and that's week one. Every week we will add new materials for the week. So you will, by the end of the course, you should have 4 folders here, week one all the way to week 4. But now we start with week 1. There are a number of files. We also have the QGIS instructions here that we are not going to get to right now. That's something Tata does in the other video, but let's start the notebook called Carto Intro Python, and this is the material for today. So what we do in tutorials, the point here is not to learn programming. Hopefully, if you're taking the Python path, it means that you already are familiar with Python, you're comfortable enough to work with your specialty in Python. If you do not know Python, then this path is not for you. You should go with the QGIS. But if you have already learned Python, or if you have taken the courses GeoPython and AutoGIS, then many of the things we go through or use here are quite familiar for you. So you do not need to, so it will not be new. So I'm not going to type code here to save time, and I'm not going to teach you how to code because I assume that you already know that. So we just look at the code and see what we're doing, because the point of this course is mainly to make a map and try to make that map, customize the map and make it look as nice as possible. So with that information, let's start our tutorial. As I said, this little tutorial is just to warm up for the course, and we start by making a simple thematic map using Python. So many of us may have already have only made maps in software. So today we will just see how we can make similar maps using Python without help of any software or any commercial product. Um, so what we do today is a static map, simple static map, and we are going to use data from OpenStreetMap. You can try this with any data you want. For simplicity, we are just getting data from OSM now. And what we are learning to do is to work with the layout a bit, work with colors, and add some map elements using Python to our map. And the goal is to get familiarized with some of the Python tools that can allow us to work with our maps. So the libraries that we'll be working with, the main libraries, one is the OSMNX. So this is not specifically about cartography here. We are just using this library to get data from OSM. If you're not familiar with this library, check out their documentation or check out the materials from our course AutoGIS or Automating GIS Processes Part 2, where we work a lot with this library. But anyway, we use it very quickly to get our data. Then we use matplotlib, which is a comprehensive library for creating static, animated, or interactive visualizations in Python. Uh, we work with some submodules, CM and colors, from this library to manage colors on our map and do some color operations. This is a very big library that is used for many kinds of visualizations, so it's not only about making maps. So you have previously probably seen this for making charts in GeoPython course or other places. And so it's not limited to maps, but it is also a very versatile tool for creating maps. Um, The third library that might be new for many of you is the Pillow library. The Python imaging library adds image processing capabilities to your Python interpreter. It's a very big library, and as you can guess from the description, it is not limited to making maps. It's an image processing uh, Python library with a lot of capabilities. So if you're working with images, you want to do different kinds of manipulation, processing on the image, this is a very good library. It's very common. It comes with a lot of functions. We're going to just use some basic things to adjust our layout and work with colors and so on. If you want to learn more about this library, again, as usual, a good starting point is the library's own documentation pages. So let's get it started in the first code. In the first code block, we are just importing the libraries we need. GeoPandas for working with the geospatial files. We have Pathlib. We have seen this in AutoGIS too. Uh, we use that for defining our path, and we specifically import some of the submodules from matplotlib to access them a bit more easily. Uh, and also from Pilo library, we again import a number of submodules that allow us to access the functions inside them a bit more easily without typing too much. So I'm going to just run this block. Then I'm going to run the second block, just defining the path to my folders. So that's just to get started with things. In the next step, we are going to retrieve our data. In our case, we're getting the data from OSM. You will be working with local files in future in your exercise, in other works, so it doesn't have to be OSMNX. But in our case, we're getting the data from OSM. Um, so what we need to do in order to fetch the data is to provide the name of the place. So I'm going to get the data from Kamppi, Helsinki, Finland. I'm a bit more descriptive here to make sure that the OSM doesn't get confused and gives me the right Kamppi in case there's some Kamppi somewhere else in the world. So I'm going to get the data using graph from place, providing the name of the place, and I'm going to get the full network and apply a bit of simplification. Let's run this. It should take a few seconds depending on how large the area is. The company is not that huge, so it was fairly fast. Now the data is loaded. For those of you who have taken the AutoGIS course, you probably remember that what is returned from this function to you is actually a tuple. So you get the nodes and as well as the edges from OSM. So nodes are the points representing intersections or intersections between the different sections of your network. And edges are actual routes, the lines that we are more interested in visualizing today. So I'm going to read the tuple um, and convert it to a geodata frame and save it under node and edges. So, and then I'm going to use the head to take a look at what I have in my data. So this is what my data looks like. These are the edges, the lines, and many of you are probably familiar with OSM. You know that this, well, you can always check the documentation to see what these columns mean. We have a lot of columns with many columns with information, like for example, the name of the street, what kind of road it is, what is the maximum speed, and we have also a lot of columns that might be missing values. I have put a table of what these columns mean here, which I have gotten from the documentation of OSM. So if you want to use this data further, this is more than enough for what we are doing now. But if in future you're doing something bigger with OSM, then of course you should check the documentations and see what you have in your data. Yeah, so we got our data. Now I'm going, and we got our data sets. Now what I'm going to do is to create my first map. So I'm going to import pyplot from matplotlib, which gives me a bit more control over the figure, so I can customize it a bit more. This is something we have seen in our previous courses. So I'm going to import it as PLT just to be short and avoid unnecessary typing. Then I'm setting the size of the plot. This is something we have done in previous courses. If you haven't done this before, please go and check GeoPython and AutoGIS first. So the figure size 10 by 10, I specify I set DPI to 100. Then I start plotting. So edges.plot. I set the axis that I want to add the data to, and colors. You probably remember that in Matplotlib we have a wide range of colors that are like defined by default. So if you check out the documentation, you can um, find the colors. I already went with some built-in color that I knew looks nice, but of course, if you're making your maps, you should go through the colors and see which one works best for your case. But this is a quick mapping right now to just view our data. We are going to further customize our map. I apply line width at 1 and I add transparency with the variable alpha 0.5. 0.5. We can of course adjust this and see how things look, how to make things better. Later we are going to drop nodes, but for now, just to see what we have, I'm also adding nodes to the map, applying some color to it, so it will be some green, the infill, and then the layout will be black color. And as marker, I would just put O, which tells Matplotlib to just symbolize them as a circle. And then I'm going to set off the axis. So it's a map. We don't need to have the axis. You would need that if you're making a chart, but in our case, map, you don't need that in most cases. So I'm just going to turn that off. And I add a title to my map. So let's just run this and see what we get as the output. So this is the data that we got from OSM. So you see the edges that are visualized using this saddle brown. So it's some shade of brown. And we have added the nodes as a green color. And we of course added a title, street network, and we bolded it and applied a font size of 15. So if you want to make this better, I advise you to play with this a bit, uh, see different levels of transparency, how you can make this slightly better. Uh, to Yeah, so let's just try that a bit here. So for instance, I can increase the transparency of the dots. So if you want to increase the transparency, you just have to reduce the alpha level. So for example, this, depending on what you're doing with your map, this might look better if the points are not so important to you. But for now, let's just go with 7 so we see what we have. And we are going to continue now working with colors and improving things. So I have added a Python file here. It's saved somewhere here. Uh, it's a visualizer, it's a color palette to visualize things. So of course you can just Google and find a lot. So this is being loaded from color palette visualizer.py. So it's a Python function that allows us to uh, visualize this. So this is basically coming from there. So if you want to play with colors and see what would work best here, of course you can Google, find color codes from different sources. But if you want to stay in CSC environment, this is one handy tool that can allow you to browse different colors and see their code, which you can use in Matplotlib directly. So we are going to talk about colors in detail next week, but for now you can just play with colors and see what would be most suitable for our case here. Yeah, so now we want to work with the colors. Uh, what we have done previously, for those of you who have taken GeoPython and AutoGIS courses, you probably remember that the data that we work with, uh, well, the data sets are rather simple and very clean. And what we did with visualization was usually to apply automatic coloring, automatic classification, and just use, um, like we took shortcuts to creating maps. So that's why we did not really customize the maps so much. What we are going to do differently during this course is to customize our maps more, because that's the point. We don't want to just get whatever automatic map that is produced by default by Matplotlib or any other library that we are using. So the column that I'm going to use for visualization, this is a bit like arbitrary, but this is just for the sake of visualization. So we are going to use the lengths of the edges because a lot of our columns have missing values here. So to get a neat looking map, I'm going to visualize the um, uh, segments, the lines of the road network based on how long each segment is. So I'm going to do a manual classification and manually apply a color. So you remember that there are these automatic classification methods or automatic ways, or there are these predefined color ranges that you can use uh, for quick visualization, but now I'm doing this manually to try to make it nicer. So for the length, I'm doing this kind of classification. So if it is less than 100, I'm going to apply a color. Let's check what color this is. I believe it should work if I just paste it here. Yeah, so it's some shade of pink. So um, yeah, so that's the starting point. Then we have 100 to 200, then less than between 200 and 400, and 400 and 800, and anything else will be visualized as white. So let's check this other color that I have included here. So the colors will range from some shade of pink all the way to black, depending on how long the segments are. Of course, these are my choice of colors, and we are going to learn better next week how to make better color choices. But now I have put the tool here, so when you're doing this, try different colors. Do not just go with what I'm showing here. Another level of customization that I'm adding to my map here is the line width. So I'm going to color my road lines based on the length, and I'm going to adjust their width based on the type of the road that they are. Uh, So in OSM, we have a column called highway. So the value, so it's a bit weird name, but it determines, it tells you basically what kind of road you have. Is it a pedestrian route or is it a highway? So there are different values for that. So I'm going to iterate through the values um, in that column in highway, and if it's a footway, so meaning that it's probably a narrow route, then I'm going to apply a line width of 1. If it's not a footway, then I'm going to just assume that it's a road for cars. Again, if you want to be very specific, you can go through the values that you have in column, but here for the sake of simplicity and just show you how to do this, I'm going to just extract footway, and if it's not a footway, I'm just going to assume it's a bigger road. So if it is a footway, I'm going to apply a line width of 1. And if it is a bigger road, then it's just, I will apply a bigger width, 2.5. And I'm going to write this to a list. Later on, I'm going to use this list to apply the line widths to my visualization. Note that we did the same thing here. So we created a list for colors, we created a list for line width, and later we are going to use that for our visualization. The next thing I'm going to do is to read the coordinates from my data. So I'm going to just use the nodes and get the extents of map. I also define a value for margin to apply a bit of margin around my map. So we will see how we are going to apply this later on in a few minutes. But it would not look very nice if your map frame ends abruptly where your data ends. So you probably want to apply a bit of margin around your data. So you know what I mean. So it looks a little bit nicer. So this is why we have included this margin level, and we are going to apply it later. But now we just defined it as a variable. So I'm going to run this cells. I guess I didn't run it before. Also for the line width, and also for reading the extents and the coordinates. So now we are going to revisit our map. So we made a very basic map up here, and the point is to customize it and make it hopefully a bit better. So we will continue working with Matplotlib and visualize our street network. Uh, so we will create a customized visualization of the graph G, which we got from OSM. We will add a legend to it, a north arrow. So we worked with legends previously, but now we see how we can further customize them. We add a north arrow. This is something we haven't done before, if you have taken our earlier courses. And we try to customize the aesthetics of the map to make it a bit nicer. Uh, so there are more details of what we are doing, what are each variables that we have included in this code. So if I will go through some of the details, but if I miss something, you can check up here what each of this means, what is bbox, what is DPI, and what are all these parameters that we are using here. So yeah, so let's look at our code and see what we are uh, doing here. So from Matplotlib, there's a submodule patches, and from patches, I'm importing fancy arrow patch. So this is a library within our Matplot library that gives you access to a number of arrows, which you can use, for example, for different purposes, for example, as a north arrow in your map. So it's nice and handy. Of course, you can use whatever figure you want. And this is something we are going to see later, how to add custom figures to your map. We are going to see it in future coming weeks. Uh, but there are a lot of built-in arrows that you can just use. For an arrow, it's probably you will most likely find something that suits your style and your map purpose. So we are going to import that library specifically from Matplotlib. And then, as usual, I'm going to create my figure and apply size and some face color to it. Then I'm going to plot the edges and yeah, so from geometry and color and width. So what I'm going to do is I'm going to visualize. So before we have just done things automatically, but what we are going to do now is to iterate through our features and read the values that we had in our colors and width and apply it. So because we created the lists and we just, well, of course, it went through the data in a certain order, so the lists are in the same order as our features. So it's just safe to just do an iteration and apply the colors and width. Next thing I'm going to do is to apply the extents. This is specify the extents I want for math by setting the x and y limits. What I'm doing here is just I'm providing the coordinates that I read up here from my nodes data, but also adding a bit of margin. So on the west, I'm of course deducting the margin, and the south and west, and on east and north, I'm adding the margin. That's how coordinates work. Um, and then I'm setting the axis off. I don't need the axis on my map. Uh, Then I'm going to work with legend. As I said a few times already, previously we have just created automatic legends, but if you want to have control over your legend, then you should uh, just customize it. So what I'm doing here is that I create a list, and with that list, I'm just creating the lines manually. I'm applying a color to them, I'm applying widths to them, and do a lot of customization. So instead of creating an automatic legend, you can create a list with the specific details of items on the legend that you can define as a legend element. And then you can add this legend to your axe using the handle legend elements. And then you can customize it further. So full details of this are in the documentation. But for instance, you can choose to have the frame on or off, how many columns you want in your legend, and the location and so on. So yeah, and font size. So we can customize it. So you define the items and the specific styles for each of the items um, in your legend and the label for them and so on. And then you can apply these items. You can tell Matplotlib that this is a legend and these are my items and this is the overall style of my legend. Next important thing we are doing here is to add a north arrow. Adding north arrow within Python is a bit complicated. Not complicated, but you have to just be a bit careful with it. And the reason is that by default, the yep, so things don't happen automatically. So you have to be careful where you want to place it and how you want to place it. So I'm defining an arrow length. Again, this is based on the coordinate system that you're using, and this is from OSM, so it's from Web Mercator. So I know the values. I've tested these values. This work nice, but you have to adjust it according to the coordinate system that you're working in. So you define an arrow length, then you specify where you want to put the arrow. So I'm going to put it somewhere on the upper right of my map. So I use the coordinates that I read. So remember that uh, everything on this map is within a coordinate system now. So don't think of it as a graphic thing like you're used to in QGIS or other software. So we are within a coordinate system. So if you want to define where the north arrow would be placed, then you have to give coordinates for it to place it exactly where you want. So this is what I'm doing here, and then I'm applying a face color for it, and specifying the scale, and then I'm adding the arrow as a patch to my map. Then we added for north label, so this will only add an arrow to our map. If you want to also add a label for it, in my case, I want to say call it N, so it's north. Then you can specify, you can add it. So you have to add a text separately and make sure it appears somewhere reasonable next to your arrow. So these are things that you have to do manually. So it's a bit tricky compared to what you're used to, adding a legend quickly in your map. So, but this would pay off if you have, like, if you want to automate the process and produce a lot of maps as a repeated task. Then once you do it, once you go through this pain, then the rest would be just happening automatically. So that's in case you're wondering why should I go through this. It is difficult to do it once, but if you want to reproduce this kind of map, then the code is there, so it will be fairly easy. So let's just run this and see what we were talking about. Uh, okay, so now we apply the map. We have applied a face color. We have manually located our north arrow here using the coordinates, the extents of my map, and the margin value we had applied. This is a legend. You can see that we have specified it. We have made it look a bit nicer. We don't have a face color. It's blending in nicely with the background. We have specified the colors, of course, the same colors that we had used here. And we have added the text, the labels for each of the items, and we have placed it in the upper left corner of the map. And this is what our map looks like. It's a bit too big for our screen, but yeah, we have this map, which already looks a lot better than the original map. Well, as you can see, we did not add the nodes anymore. Of course, it depends. Does it make sense for your case to have intersections mapped as points? If not, then you don't need to include it because overcrowding your map is not a good idea. So what I'm doing here is that I just left it out because I want to just show the road network and visualize them based on the color. So a lot of them fall into the same category. So we have a lot of that pink category. It would be a good idea to work further with your customization, with your classification, and make this look a bit even better. Again, classification depends a lot on what you want to show. So you cannot say this is bad. It just depends on what you want to show in your data. Uh, Yep, so that was the uh, well, we saw for placing things, for placing, for example, the legend, you can just verbally say that you want to place it in a certain place. You can say, I want to put it to upper left. That's what we have done here. If you check out the documentations, you can see that there are ways you can anchor it to a certain place to your map. So the values range from 0 to 1 in every direction. So you can play with this. So instead of verbally saying where you want your items to be placed, you can also work with anchor. This is helpful this is helpful if you really want to customize where the item is located. So in our case, I'm happy with where our legend is appearing on the upper left with a bit of margin to the upper and left ends. But if this was overlapping with your data, then you should move it around. So if you can do it using these verbal values, upper left, upper right, lower left, lower right, then perfect. If not, then you can use the anchor values and adjust exactly where you want to put things. It is also possible to combine the anchor values with the variable values and get more specific. Uh, well, it will work a bit different. You can put things even like outside the axis if that's what you want, if you want it to be outside your frame. But yeah, you can spend some time playing with this, but in our case here, this just worked nicely, so I'm happy with the solution. Next thing I'm going to do is to do some image processing using the pillow. So everything we did so far was basically the same as what we had learned before in our courses, with the exception that we customized our legend a bit further. We added the north arrow and we did a manual classification and applied the colors and line widths uh, manually. So that was the major difference so far. Another new thing we are doing now is image processing. As I said, Pillow is a very powerful big library for image processing, and what we are doing here with it is a very simple task that it can be uh, done with this library. So here we will have a small demonstration of how Pillow can be used to add features to your map images. So maps are basically images. To Python, it's just an image. So you can use Pillow to do image processing. And this can be anything. You can like anything that, for example, you can do in a software for image processing, like Photoshop. You can do it programmatically. Well, not everything, but a lot of those things can be done programmatically using Pillow and probably other similar libraries. So what we are going to do here is to add features to our map. In this case, we are going to use Pillow to dynamically add a colored border to our already existing map. So I'm going to add a colored border to my map and add the title into that box. This can be, for example, useful for emphasizing certain aspects of your map if that's something you need, or in our case, I want to just do it as a practice and also to improve the aesthetic appeal of my map. Um in this example, we are using the add border function that is used to add, in our case, we are adding a significant border, 800 pixels, because we are going to use it as a box and apply a reddish color that suits the colors we have used in the map. And then inside that, I'm going to add a text, which will be the title of my map. So to make things easier, I'm going to define a function. So this is useful if, for example, you're going to do this many times, add this kind of layout to many maps. So I'm going to add a function that takes an image as input, produces an image as output. You can also specify what color you want to add as uh, what kind of color you want to add as the infill color, and also specify where you want things to be placed. So what it essentially does, it opens the files, it calculates the new width and height, because when you are adding something to your map, you're readjusting the size of your figure. So the figure should get bigger or smaller depending on what you're changing. So in this case, we are resizing the image using the size of the border that we want to add, and then we create the new image and apply the fill color, and then so what we are doing next is to apply, so we are pasting. So now we created this bigger image, we applied an infill color for it. What we are going to do next is to paste the original image on top of this old one. Then this way we will have whatever we have added, the background, this will be pasted on it, so we will have a combination of the newly added features and the original file, which was our map, which we produced just earlier. And then I'm going to save it as output. I'm running this function with our map PNG, which is something we just created up here, map.png, and then I do some resizing, mainly to make it look nicer in our Jupyter notebook, and then I'm going to visualize it just here. Oh, I skipped one step. Let's run this first. Okay, I ran them in wrong order, so the file got deleted. I will reproduce this PNG file. So this map PNG is now recreated. What I'm going to do now is to run this block. Now it should be able to find the PNG, the map PNG map.png file. Okay, so now the process is done. What I'm going to do next is to now we have created our map with the border added at the bottom of the map frame. Now we will continue our image processing by adding a text. So I want to add a text to the box. So I have added, you will see this shortly, I have added a red box to the bottom of our map, and then I'm going to add the title of our map there. Then I will further resize the image to make sure it fits better on this smaller screen. And of course, we have used the same file for the course's website to make sure things don't get messed up. Then I have adjusted the size. Then depending on what we are going to talk about printing and displaying and different map media later on, but depending on what you're going to use, you can choose what size you want to produce your map in. So I'm going to run the next cell. So this is the output of the map. So this is what we had. Then we created a red image. So we created a new image which was a bit larger in width, in length. So we added the red color to it. Then we pasted this image to this new image. And then what we are doing in this next step is to apply a bit of text. So we draw on our image using the pillow function. Of course, we open our file first, we draw on it, we specify what font we want, we use we load the default font. So what you can do is to use specify. So if you use image font.trueType, then you can specify the name of the font you want to use and the size. I have commented this out and I'm going with the default because we are running this on CSE. I don't have much control over like what fonts are installed in this environment and I don't want to work with it too much. So I just went with the default to avoid errors. But if you are doing this on your own computer, for example, or if you feel like installing fonts, then you can just use whatever font. You probably can also provide a link to the font directly here. But for simplicity, I'm just going with the default font, which is probably some version of Arial. So I'm using that and I specify the size. This is again something I've played with. I came up with the right sizes for my map. You can play with these values and come up with something better. Then you specify where you want to add the text and what is the uh, text. So I'm writing just copy Helsinki and of course the font and everything you had defined before. And then I'm going to just save the map. Here I'm deleting the file. If you want to keep it, this is that intermediate file that was created before adding this border. If you want to remove that, just keep this on. If you want to save it, then just comment this out. And then I'm readjusting the size of the map. So remember, one thing I'm doing here is that I'm resizing while maintaining the aspect ratio of the map. So, if you just resize your map in a certain direction without respecting the aspect ratio, it's going to get messed up. So you don't want that to happen. So what I'm doing here is I'm calculating the aspect ratio manually, and then I'm defining the new height and size using the aspect ratio so the ratio of the uh, map doesn't change. So this is a simple map. This looks good compared to a default map that you would normally get from Matplotlib. There is certainly room for improvement, and that is something that you're going to do in your exercises. You don't have to work with the same data, but you can use the same data or something else, try to improve them while you're working on the exercise. Try to think about some of these questions. Are there elements that we are missing here? We have a legend, we have a north arrow, we have a title, but is there something that we are missing? Are the colors good? Is the choice of this color combination good for this map or not? Are you happy with the classification, or can you somehow still improve the classification, or how would you do it differently to create a better map? Uh, and another thing with colors, here we have values ranging. This is the length of the uh, segment, so it can range from anything, any small amount to bigger amount. So we have an order here. Is the color choice here representing that hierarchy? So if you look at uh, this map, do you intuitively see that red is smaller than 800? So white, which is anything bigger than 800. So these are some of the things that need to think about, and we are going to revisit this topic next week. Uh, yeah, so that was it for exercise for tutorial. I will briefly talk about also the exercise one. So with the first exercise, in future exercises, you will have a bit of more uh, f- uh, instructions what to do. But in the first session, the idea is to explore how you can create map based on what you learned today and things that you have learned previously. You all have some experience creating some maps, so you have a bit of freedom what to do, what kind of data you want to use. We have some suggestions where you can get their data from, but it can be basically any vector data from Python or Helsinki InfoShare or any other open sources. You can get accessibility data, population grid, traffic data, and all you need is just a data set that has a story to tell, and we are going to visualize it. So some key points to consider. Today we worked a bit with layout, so think about how you're doing the layout. Color choice is something we are going to talk about more next week, so it's not the main thing, but I still try to do your best, choose suitable colors. We have talked about projection in the class, so think about projection and map elements. We have talked about them, include essential map elements. Do not put anything that is unnecessary, but the decision is up to you, so you can decide. And aesthetics, try to make a nice looking map using whatever skill you have. Uh, and then submission. So submit your exercise on Moodle as a PDF. In addition to your map, the map you produce, of course, you have to explain a bit what is the map about, what data you have used, and also you have to add a bit, you need to add also a bit of reflection, what you have learned from this week's lecture and discussion, highlight how these insights were incorporated in your map, provide an explanation for some crucial decisions. So if you decide to add a certain element to your map, explain a bit why you have made such decisions, describe what your map reveals, what were the cartographic decisions that influenced the map and will influence the interpretation of the map users, and reflect on what you wish to learn uh, from this course to improve this. So the map is not perfect. The map we are making the first week, well, we can never make a perfect map. It's hard to say that a map is perfect, but we are trying to get as close as possible. So reflect on that and see what you would like to learn during this course that would help you improve the map further. You will get 10 points from this exercise, 3 coming from map quality, 3 from learnings, and 4 on cartographic reflection. So a lot of this exercise is about reflecting on cartography and your skills as a cartographer. And the deadline for this is 15th of May, end of day, submit it as a PDF to Moodle. Okay, I would like to quickly show you one thing. We have a notebook file called projection. We might have looked at this during the class, but it works now more nicely in CSC environment. So this is a tool we have created for you to explore the importance of projection on your map. So I'm going to import some libraries that allow us to do what we are doing here, some GIS libraries, but also some libraries specifically for Jupyter Notebook Lab to provide this interactive feature here. So we talked about the importance of using the right projection. Um, And here in this interactive tool, you can see that we can try different projections. I have included some options for you, but if you want to try out something, of course, you can add more to the options. And here we have a drop-down list, so you can just choose different kinds of uh, projections and get an idea how this would affect the looks of your map. So this is a handy tool to give you an idea how this can affect things. Uh, So this is of course a global level map. If you are uh, on a local level, also there are different considerations you need to take into account. Let's see how these different projections would affect our local map. So this is, let's just try a Mercator projection for our map. So this is with Mercator projection, it has a bit of delay. So this is how Finland looks like. If you use a Mercator projection in your work with Robinson, looks like this. So the point here is not to say which one is better. Of course, you have to make the decision wisely based on your purpose and the study area, but the point here is mainly to show you that choice of a projection system significantly impacts how your map looks like. So you should be careful when making the decision and take a number of things into account. Okay, see you next week.